Hello students, welcome back to our channel Diksha Karnataka. So in this video, I'll be discussing part 2 of mock test 7 where I'll be discussing question number 31 to question number 60. I hope all of you have downloaded the question paper and have also solved them. If you haven't downloaded the question paper yet, the link of the question paper is there in the WhatsApp channel and the link of the WhatsApp channel is there in our description box. Okay, so please go to that. Download the question paper, solve them religiously and then come back to check your scores and check the solution. So let us start with the first question. We have, this is a theoretical question, which of the following statements is not correct? Okay, so it's about quantum numbers. The shape of an atomic orbital depends on the magnetic quantum number. Okay, let us read that. The orientation of an atomic orbital depends on the magnetic quantum number. Next, the energy of an electron in an atomic orbital of multi-electron atom depends on principal quantum number. So here you should know that the energy not only depends on principal quantum number but also on the azimuthal quantum number, right? So that is why this statement is not correct. So correct answer for this question is option number C. Now the number of degenerate atomic orbitals of one type depends on the values of azimuthal and magnetic quantum number. Yeah, this is also correct. So the correct statement is option number C. Now let us go to the next question. Which of the following is incorrect for SF4? So if you know, sulfur has 6 valence electrons and out of that 4 is used in bond forming bond. So 2 unpaired electrons are there, non-bonding electrons are there. So we can have the structure is like this, SF4, okay, and with 1 lone pair. So this is 1, 2, 3, 4, 5, sp3d hybridization, that is correct. It has 2 lone pairs of electrons, this is incorrect, it has only 1 lone pair. It has 4 bonding electrons, yes, these are 4 bonding electrons. It has a seesaw shape, that is also correct. So the correct answer for this question is option number B. Okay, now let us see next question. For the reaction at 25 degrees Celsius, X2O4 gives 2XO2, delta H value is given, delta S value is given, we have to calculate the reaction. So the condition for the reaction to be spontaneous is delta G should be negative. And what is the formula for delta G? Delta G is equal to delta H minus T delta S, right? So delta H value is 211 kilocalories. So we can convert it into calories. Okay, minus 2 delta S, 298 into 2, right? So you can see this number will be coming a positive value, right? To this much big number subtracted with this small number will get a positive value. So delta G is positive. So the answer for this question will be, it will be non-spontaneous because delta G is positive. Okay, so the correct answer for this question will be option number B. Now let us see the next question. The reaction in which delta H is greater than delta U is. So for this we have this equation. Delta H is equal to delta U plus delta Ng RT. Okay, so I can write this equation like this, is equal to delta Ng RT, right? Now if this value, okay, if this value has to be positive, then delta Ng value has to be positive, right? So delta Ng value, how to calculate whether it is positive or negative, you can check here. This one, if you see, this is 2. For the delta Ng value is the number of gaseous moles of product side minus number of gaseous moles in the reactant side. So 2 minus 1, 1. So we'll get 2 minus 2, that is 0. So that means delta Ng is 0. So delta H is equal to delta U according to for option number A. We'll neglect that. Now for this one, if you see, it is 2 minus 4. That is minus 2. So delta Ng will come negative. That means delta H is less than delta U. Now if you see this one, this is also solid. So here delta Ng is plus 1. Right, 1 minus 0. So if this is positive, delta Ng will be positive, delta H will be greater than delta U. So the correct answer for this question will be option number C. Okay, next. The trans alkenes are formed by the reduction of alkynes with. So this is a name reaction, Birch reduction in the presence of sodium liquid ammonia. Correct answer is option number C. Next. Which has the maximum number of molecules? So what we can do is just calculate the number of moles for each one. So 7, so number of moles for option number A is 7 by 28. For option number B, it is 2 by 2, that is 1. For option C, it is 16 by, if I add this one is 14. And then here we have 32. So we will have 46. 16 by 46. Then for option C, it is 16 by 32. So you can see all these numbers will come less than 1 and this is equal to 1. So the correct answer for this question will be option number B. Okay, so if number of moles are more, number of molecules will also be more. Now see, let us see the next question. The shape of ClF3 according to Vesper theory. ClF3. Cl has 7 valence electrons, right? And there are 5 electrons are used for bond formation. So there is 1 lone pair. So I can say 5 bond pairs and 1 lone pair. So the steric number is 6, right? So if you see here, ClF3. So there are 3 fluorine group and okay. So we will get this one. So here you can see here. We have chlorine has 7 valence electrons. Out of that, 3 electrons are used for bond formation. So 4 is left. So I'll write here number of bond pairs is 3. Number of lone pair is 2. So steric number is, or the coordination number will be 5, right? So that means we will get T shape. So correct answer for this question is option number B. Next. The pH of 0.05 molar barium hydroxide is. Okay, this is very important question. First of all, what the formula that we should know is pH is equal to minus log of H plus, and one more relation, pH plus pOH is equal to 14, and one more relation, pOH is equal to minus log of OH minus, right? So now if you see here, what is the concentration of OH minus? See, from 1 mole of barium hydroxide, we'll get 2 moles of OH minus, right? BaOH whole 2. So from 0.05, the number of moles of OH minus will be 0.1, right? Now pH will be equal to, pOH will be equal to minus log of 0.1, or I can write it as plus 1. pOH is equal to plus 1, then pH will be equal to 14 minus 1, that is 13. So the correct answer for this question is option number B. Next, which of the following elements will have the highest second ionization enthalpy? Means to remove the second electron will require more energy. Okay, so if you see here, we will require more energy to require the first electron because it is in the fully filled orbital. Now if you see option number B, first electron we can remove easily because it is half filled. But when we go to the remove second electron, it is from a fully filled orbital, that is 2p6. So here you will require more energy. Now if you see here it is not not much difference because it is already unfilled. Here also same thing. So the correct answer for this question will be option number B. Once again I'll repeat here. Here removing first electron will be very difficult because s orbital is fully filled. Here removing first electron will not be difficult, but removing second electron will be very difficult because it is from 2p6 orbital which is fully filled. Okay, so the correct answer for this question is option number B. Next, the functional group of acid anhydride. Okay, so acid anhydride, you know, this is a group like this. Okay, so the correct answer for this question is option number B. Okay, next, which of the following process delta S is negative? Okay, so delta S is negative when the entropy decreases. Okay, if the entropy is decreasing, we can say that delta S is negative. Now if you see here, means more randomness. This was molecule, and here we are having 2 atoms. So the randomness of 2 atoms will be more. So that is why this one will be positive. Delta S is positive in case of option A. Now here you see N2 gas is 1 atm, N2 gas at 8 atm. So when you give more pressure, okay, so the nitrogen molecules will come more close to each other and they are comparatively more arranged as compared to this one, right? So here the randomness is decreasing. So delta S is negative in option number B. Now if you see here in the reactant side there were 2 molecules of gaseous state, and now here there are 3 molecules in the gaseous state. So number of molecules in the gaseous state has increased, so entropy has increased. Now if you see here diamond to graphite, as you know diamond is more compact as compared to graphite. So when it goes from diamond to graphite, the randomness increases, delta S is positive. So the correct answer for this question will be option number B. Okay, now next, oxidation state of P in this one. Okay, so let us calculate this one. First, barium is a group 2 element, so for barium it is 2 plus hydrogen there are 4, so we can take it 4 plus 2x. Okay, next we have 4 oxygen, each oxygen is minus 8, so we'll get 0. So if you solve this, 2x is equal to 2, so x will be equal to plus 1. So the correct answer for this question is option number C. Next, The IUPAC name of the compound. Okay, so here first of all you should know the priority group. This is COH has to be first priority, then second, then this one, right? So what is the functional group attached on the second carbon? That is amino group, and the functional group attached to the third carbon is OH group. So the correct answer for this question will be 2-amino 3-hydroxy propanoic acid. Okay, so the correct answer for this question is option number A. Okay, next, the incorrect statement regarding glucose. Okay, so glucose on reduction with HI red phosphorus forms N-hexane. This is the correct statement. Glucose does not react with hydroxylamine. This is incorrect, right? Glucose reacts with hydroxylamine, and we get a conclusion that some carbonyl group is present, right? So this statement is incorrect. Next, glucose on oxidation with bromine water gives gluconic acid. This is also correct. Glucose on acetylation forms pentaacyl derivative. This is also correct because there are 5 OH groups, right? So the correct answer for this question will be option number B. Okay. Next, each polypeptide in a protein has amino acids linked with each other in a specific sequence. This sequence of amino acid is said to be the primary structure of protein. Another thing that you have to remember here is during denaturation, the primary structure remains intact. Okay. Next, in DNA, the complementary bases are, this is very common, A form bond with T and G forms bond with C. So we have adenine and thymine, guanine and cytosine. So the correct answer for this question is option number C. Next, the best reagent for converting 2-phenylpropanamide into 2-phenylpropanamine. Okay, so we'll draw first this one, 2-phenylpropanamide. Okay, so we have this one, 2-phenylpropanamide, and then we have, sorry, one more carbon we need. Okay, so 2-phenylpropanamide, and then we have 2-phenylpropanamine. So we will have this one too. The conversion is 2-phenylpropanamine, right? So you can see here there are same number of carbons in the reactant and product. So we cannot have bromamide degradation. So reduction of this group can be done with LiLH4. This one in ether, right? It is a reducing agent. It will make it CH2O2. So the correct answer for this question is option number D. Okay, now seeing the next one. The source of nitrogen in Gabriel thalamide synthesis is, we have this potassium thalamide. This reagent is used, right? So the correct answer for this question will be option number D. This is direct name-based, reaction-based question. You must be knowing this one. Next, in the following reaction X, this compound is given. You have to find the product. Okay, so let us see first. We have this C cyanide group is there. When you do SnHCl, it is reduction. So what I will get? Here we will get CH2 NH2. Okay. Now if you do NaNO2HCl, so if you have remembered, if amine groups are attached to the benzene ring, they form disonium chloride. If it is attached to the aliphatic carbon, it will form alcohol. So what will happen? This group will be replaced with this one, CH2OH. Okay, so the correct answer for this question will be option number B. Now let us see the next question. Which of the following reagents are used for detecting the presence of carbonyl group? Okay, so carbonyl group can be detected with this one, right? It is like in the question is it relevant to determination of glucose structure. So with hydroxylamine, with NH2 hydrazine also we can get, with NH2OH also we can get. This one cannot tell us. So the correct answer for this question is both A and B. Okay, next, under Wolff-Kissner reduction, conversions which may be brought about are. Okay, Wolff-Kissner reduction, if you remember, it converts any carbonyl group to alkane group, right? So you can see just by seeing the options, here alcohol is produced, here alcohol is produced, here alkane is produced, and here again alcohol is produced, right? So by very easily we can say that the answer has to be option number C, because the end product is an alkane group, it is not an alcohol group. Okay, so correct answer for this question is option number C. Now next, which of the following acids has the smallest dissociation constant? So see here, smallest dissociation constant means it is a weak acid, okay? Weak acid means the conjugate base is unstabilized. Now let us see the option. You see here also it is fluorine, here we have fluorine, here we have bromine, and here we have bromine. So first of all, fluorine will stabilize better than bromine. So that is why we can eliminate these two fluorine options. Now here also bromine is there, here also bromine is there. So now bromine has minus I effect. So distance will play a role. Here you can see this bromine is nearer to the acid. So this one will stabilize more than this one. Okay. So the correct answer for this question is option number C. Okay. Now let us see the next question. Which among the following reactants and products are not correctly matched? Okay, let us see this one. Here we have CH3CONaOH with NaOH. This is your aldol condensation, you can see. So product is correct. Here we have ammonia derivative nucleophilic addition. This product is also correct. Here it is formation of cyanidine. This product is also correct. Okay, these are correct. Now if you see this one, CH3COH 2 times plus KOH. This reaction has to be similar to aldol condensation, right? But here the reaction is given different. So the correct answer for this question will be option number D. So the correct answer for this question will be option number D. Okay, now let us see the next question. Iodoform can be prepared from all except. So what is the condition for iodoform reaction? We should have either this group, okay, or we can have this group, right? So we have to find out which group is possible. Now if you see isopropyl alcohol, okay, isopropyl alcohol has this structure, right? So this group can show you iodoform reaction. Now if you see 2-methyl butane 2-ONe, right, 2-methyl butane 2-ONe. So this is the structure, right? Sorry, 3-methyl butane 2-ONe. So we have this structure for here, right? So now this group CH3CO group is present. So this can also show iodoform reaction. Now if you see isobutyl alcohol is this structure 1, 2, 3, 4 and 5, right? So you see this group cannot show you the iodoform reaction because what I need CH3CHOH. This is what? CH2OH, right? So this compound will not show the iodoform reaction. So the correct answer for this question will be option number C. Now let us check this one also. Ethyl methyl ketone is there. So if we draw, obviously methyl ketone is there, right? So this part is there which can show you the iodoform reaction. So the correct answer for this question is option number C. Next, among the following alcohols, the one that would react fastest with concentrated HCl and anhydrous Zn chloride. So this is your Lucas reagent. We know tertiary alcohols will react faster. So this one, let us see all the structure. 2-methyl propanol. So we have this one, 2-methyl propanol. This is primary alcohol. 1-butanol. So this is also primary alcohol. 2-butanol. This is secondary alcohol. Okay. Next we have 2-methyl propane 2-OL. So we have, so this is a tertiary alcohol, right? So it will react faster. So the correct answer for this question will be option number D. Okay. Now let us see the next question. We have phenol on treatment with alcoholic KOH and chloroform gives. So this is very common reaction. Phenol, okay, on reaction with chloroform and alcoholic KOH. So I hope many of you will be knowing the answer, but I want all of you to comment the name reaction for this in the comment section. Okay, let us see how many of you have remembered. So this is there, OH and then CHO we will get. So this is salicylic aldehyde. So the correct answer for this question is option number A. Please comment down the name reaction for this in the comment section. Now, which of the following has the maximum pKa value? So see, this is very tricky question. Maximum pK means highest pK. Okay, we know pKa and acidic strength are inversely proportional. So if it is highest pKa, then the acidic strength should be lowest, or I can write lowest acidic strength, right? That means how to find the lowest acidic strength? The conjugate base should be very unstable. Okay, so now you see here, this is primary one. Here only one CH2 group is there. Here also one CH2 group is there. Here this is a secondary alcohol, but this one is a tertiary alcohol, right? So the conjugate base formed here will be more destabilized due to the inductive effect of so many alkyl groups. So the correct answer for this question will be option number D. Means this compound which is given in option D is least acidic, and that is why it has the maximum pK value. Okay, now let us see the next question. SN2 reaction. For SN2 the order is primary, secondary and then tertiary, right? So this is CH3Br plus OH, CH3OH Br, that is there. Here what is the thing? Here also it is happening, but this is some so it should be less sterically hindered, right? Less sterically hindered. So this one is also primary. Okay, CH2. So actually the structure is, I think, CH3 CHBr. Okay, so this is also tertiary, so we cannot have, this is secondary, we cannot use this one, this is wrong. Here, so this is not at all a nucleophilic reaction. This is tertiary, so here it will be more, this one will be the less reactive towards SN2 mechanism. So the correct answer for this question is option number A. Primary haloalkenes will react faster, then secondary, then tertiary. Okay, next. In the following reaction, the product X is, so we have first C6H5, CH2Br. Then when we have magnesium, we will get C6H5, CH2MgBr. Then if we have this hydrolysis, we will get C6H5, CH2, this will be replaced with H, right? So we will get the correct answer as option number C. Now let us see the next question. Which of the following is the correct method of preparation of methyl fluoride? Okay, so this is your, okay, for this question also I want all of you to comment down the name reaction for this one. CH3Br plus AgF will give you CH3F, so and AgBr. So the correct answer for this question is option number D. So please write down the name reaction of this one in the comment section. Okay. So these were the part 2 of your mock test 7, where we discussed from question number 31 to question number 60. I hope all of you have attempted the paper. All of you have done it religiously and seriously. So please comment down your scores so that let me know how you are doing, how is the preparation going on. And if you have any doubt in any question, please comment down. I'll take it in my next video. And all the very best for your exam. Please keep working hard. If you have found this video useful, like, share and subscribe our channel so that you'll get more updates about your preparation. Thank you.